Center, and he's done a lot of work for years here in the Sonoita Valley and then also in the Upper Santa Cruz area on soil moisture, among other things. But I'll let Bill fill you in.
I'm here from the government, and I'm coming to bring you some acronyms. The first one is SMAP, which is Soil Moisture Active Passive, and it is a big NASA effort. So in 2010, National Academy of Sciences said we're spending a lot of money on the satellites. What really are our priorities? And the first goal for NASA that came out of this Blue Ribbon panel was really to get a handle on soil moisture. So there was a historical effort with various sensors and whatnot, but this is big science. 900 million, almost $1 billion spent on it. And I will let NASA speak for themselves here in a second. And then the part that brings in the science on the Sonoita Plain is this summer we have a validation experiment that includes part of the Sonoita Plain.
For audiovisual purposes, can you talk from over here?
I'm just going to switch over here.
Okay.
Big crowd that works on this. A lot of folks from the ARS Hydrology and Remote Sensing Lab in Beltsville, and then folks from our lab. So let me switch over here if I can not get tripped up.
Our future is all about too wet or dry, too dry really wet, and you need water for plants to grow. SMAP will help address this issue by tracking water around the globe.
SMAP is an acronym for Soil Moisture Active Passive. It's a satellite that studies the Earth's moisture content, where it is, where it comes from, where it goes.
Soil moisture plays a very active and vital role in the water cycle, and we all depend on it in ways that we don't realize every day.
Every 3 days, we'll have a soil moisture map of the entire Earth, and it will allow scientists to track water availability around the globe, which will also help in guiding policy decisions.
We can use the data to help forecast crop productivity, conditions for floods to occur, the extent of drought, risk for wildfires, and also for vector-borne diseases that can occur in regions where there's lots of surface water.
And it'll help us mitigate the impacts that these phenomena have on people's lives. Soils are like sponges, they can hold a certain amount of water. And if we know the amount of water in the soils, and we know that there's a big rainstorm coming, for example, and that the soils are near saturation, then we can predict that that area might be at risk for flooding.
When there's a lot of moisture available in the soil, it can support stronger thunderstorms. So being able to understand the soil moisture state is also useful for weather forecasting in the near term.
We're going to launch on a Delta II launch vehicle. It goes into a polar orbit around the Earth, and we deploy a giant dish. It's a 6-meter reflector, so it unstows like a camp chair would.
What the big spinning antenna allows us to do is to make the measurements over a very wide swath, 1,000 kilometers, and that's the secret to our being able to make our measurements every 2 or 3 days.
This is the first time that such a large deployable mesh antenna is being used for microwave remote sensing application.
We don't ever do the same thing twice. And SMAP follows along that same formula.
It's vital to help us understand what our planet's doing, as well as to support these applications that will touch everybody on the planet in a fairly significant way.
The measurements are really important. In terms of our future, one of the biggest issues is water, and SMAP will help us better understand this mobility of water from one place to another. I think it has the potential to touch everyone's life.
Okay, so that's one one piece. The next piece is a little bit more where SMAP might touch your life here. So Susan Graham with our lab is the chair of the applications working group for SMAP. You'll see her on this film. So we cut this down. It was a 15-minute little film, and I cut down the two most interesting applications, I think. And then we'll go ahead and talk a little bit more.
In addition to their scientific value, these data will be immensely valuable for a number of applications, from weather forecasting to disease control. And the scientists behind SMAP have been working with end users throughout the mission to ensure that the data will be suited towards their needs and easily assimilated into their operations.
SMAP has a really rich heritage. It goes back over 15 years. It started off as Hydros and developed into the SMAP mission. And so it built up this really great community of people that have an interest in using soil moisture data. And so that community is known as the Applications Working Group. And from that community, we grew what's known to be as the early adopters. We identified 25 early adopters, and it's continuing, I say 25, but it's continuing to grow. We'll probably have 30 or maybe 40 by the time we launch. And these early adopters are using their own resources to prepare for the launch because they understand that soil moisture and freeze-thaw information is going to be important for their decision making.
The early adopter program was meant to capture the most dynamic and the most focused and motivated of all the institutions who are being engaged with through the application program to get them to use satellite data as early as possible.
What we asked them to do is also provide some feedback. What was their rate of success in whatever they were forecasting, predicting, or monitoring before and after the availability of smart data? I want to see that difference in order to bring it back and do the project, data product generation in effect.
This video tells the stories of the SMAP early adopters. This diverse group of businesses, government agencies, and organizations represent the end users for SMAP data, and their collaboration on the SMAP mission ensures the integration of these data into operations that affect our day-to-day lives.
The National Drought Mitigation Center is a unique center in that we are the only group in the United States that focuses completely on drought monitoring, drought early warning, drought planning. We have a very able group of scientists and staff that work on this mission continually, and it has evolved over the years. The group has started about 20 years ago now, and we've definitely evolved over time into the mission that we focus on reducing drought risk across the country.
Soil moisture is really a critical component into understanding drought and where it's developing, how severe it is. Traditionally, soil moisture information has been acquired through ground-based measurements or probes in the soil, which are few and far between. So we're interested in SMAP to give us more detailed information on soil moisture variations across large areas and really fill in the gaps between where these sensors are on the ground to give us a more detailed spatial view of how things are changing in the soil over time.
As we get these data at a higher resolution, covering the entire country, we're going to do our jobs better. When you see the drought monitor map coming out each week, we're going to have more confidence in some of the inputs that we're looking at, especially with regards to soil moisture, are going to be of a higher level and of a greater quality and more utility than anything we've had up to this point.
The IRI is a research institute hosted by Columbia University that seeks to help society understand, anticipate, and manage the impacts of climate variability, particularly in the developing world. Efforts to help rural populations cope with the impacts of things like drought and floods requires the ability to anticipate those impacts.
We are trying to test the utility of smart soil moisture products to improve the prediction of crop yields. If we have better soil moisture data, then we can correct better our models. And hence, the expectation is you will have a better estimate of your yield.
SMAP provides a great deal of promise for improving the accuracy and potentially the lead time of model-based forecasts of food crop production for food security, early warning, and management. Our hope is that this will allow food security response organizations to anticipate and act on the threat of food insecurity driven by things like drought much earlier in a way that will protect not only the lives but the livelihoods of rural populations that are vulnerable to the impacts of drought.
The SMAP early adopters featured in this video represent only a portion of the full early adopter program.
So much for the professional part of the presentation. So, there are a number of products that SMAP is going to provide, and we're going to ignore most of them. These colors are how long you have to wait until you have the product. So, really, we're interested just in this soil moisture product that comes special resolution of 9 kilometers every 36 hours, and it's really just the top 2 inches of depth in the soil. And again, the active passive part is radar that's pretty high resolution, and the passive is this radiometer product, and so they're merged and you get a 9 kilometer product in the end. How much moisture is in that the top 2 inches, and a lot of what I'm going to show is stolen from the 2012 SMAP vegetation experiment, where the goal is they're spending almost $1 billion on this. How do we know the science is good? So there's a big associated research project looking in the field. How do you compare what's measured in the field, which brings in the Ag Research Service, and NASA takes care of the science and the algorithm development. So validation is the process of assessing by independent means the quality of the data products derived from system outputs. And they've got a number of different methods: core validation sites, sparse networks, satellite products, models, and field experiments. And for example, I don't know if you guys are aware of the Soil Climate Analysis Network, the NRCS runs here in red, or the Climate Reference Network in blue. Those are some of the sparse networks. And here's worldwide picture of some of the sparse networks. But they also have core validation sites. In Walnut Gulch that we run around the town of Tombstone, 150 square kilometers of a pretty densely instrumented watershed, is one of the core validation sites. So you have to meet a number of criteria. And here we are right here, one of a number of sites around the world. And then in terms of field experiments, there have been a number going on. And the one that's being conducted this summer is the SMAP vegetation experiment 2015. And the reason we were selected is because of the monsoon storms that are so spotty. It lets them check soil moisture here, and it didn't rain right next door, which most people think is a problem, and we think it's a virtue. Scientists, this experiment is a virtue. So in the month of August, for 3 weeks, there's going to be this intensive field campaign. And every 3 days or so, the satellite comes over about 6 o'clock in the morning. There are 3 different aircraft that are going to be flying at about 6 in the morning. So if you wake up early to walk the dog, you see a plane flying with one of these pods underneath. That's what they're doing. And they've got these flight lines that start here by Green Valley, go across, and most of you probably are familiar with Google Earth, like we have San Pedro here, and then this is the Sonoita Plain here. So dividing this area up into small squares, so each one of these is 1 kilometer. And then what they're trying to do is get as many observations as they can to compare what they're measuring from the satellite and the airplane and on the ground. And at the same time, there's also a global precipitation mission where there's a constellation of satellites looking down, so these radars will be looking up, and they will complement what we're getting here from the NextRack pod. So here's the Santa Rita Experimental Range, Empire Ranch, and the Rose Tree and Walnut Gulch, if you're not familiar with them. So these yellow points, here's the research ranch. These yellow points are places where we have in place soil moisture measurements with what's called a Vitel probe at 2 inches. So those are continually reading, and then there will be an additional about 70 sampling instruments that will be placed in the field. These will, on the Empire Ranch, they'll go with the tipping bucket rain gauges that TNC and BLM installed. I don't know if we'll get all of them, there's probably not these upper ones, but and then so here are some of the other sites, and here's what's good, the additional sites on the Gulch will look like, and you can see we'll get a lot better spatial distribution of measurements, and same thing on the Santa Rita as well. I have at least one measurement in a bunch of these square kilometer areas. So if you want more information, you know how Google works. Just look for SMAP, and if you want to see the rest of the video, has a few more applications like the National Ag Statistics Service. We have that video on our website. And if I could just steal another minute, if you're interested in science on research questions, October 17th is the RISE conference in the U of A. So it focuses on research in semi-arid environments, so research on the Santa Ritas and on Walnut Gulch and everywhere in between. So that's it. If we have time for questions.
We have time for a question too.
Do you think they'll have some results by this time next year?
Yeah. Shouldn't even be that long.
I'll hold you back.
So you said it'll be measuring soil moisture in the top 2 inches. Do we have any sense yet of how precise those measurements are going to be?
That's one of the things that should come out of the field experiment. There's a whole issue of how rocky the soil is. I mean, if you're driving along looking at rock outcrop through the hills, and you're thinking, we're averaging in this area in 9 kilometers on a side. How's that going to work? So, lots of technical issues. Jane.
Is another federal agency like the USDA coupling some of their ground truthing work on vegetation with your findings?
This group, to some extent, is, yeah.
Good.
Not enough.
For Phil's taste. Probably Steve too. Any other questions for Phil? Okay. Thanks, Phil.